So hello and greetings to you all. Today we'll be looking at building a simple calculator using basic electronic components like resistors and some other display and a microcontroller. Okay. So the aim of all this experiment or this project is for us to explore how to build basic appliances and devices that we see around today. For us today is a simple calculator. And the calculator will perform basic arithmetic operations like addition, subtraction, multiplication, and division only for now. So the objectives is for us to learn how to work with resistors and potential divider circuit, okay, and also to work with microcontrollers and maybe study a little about them. And we can also understand the fundamentals behind some components we see around, okay. So for this project, we will need a potentiometer, we will need a 4/7 segment display, we'll talk about them later, two push buttons, okay, and then we need a power supply. So a power supply that supplies voltage and current. This is called a breadboard power supply. It comes in various forms. So this is one form and this is another form. And this how to power it up. Okay, so you can use the adapter or you can use the USB cord. So as you can see, it has a black input and a USB port. So you can use any of which to power them. Then there's a breadboard, so a certain housing for which you do all the connections on. Okay, and this is the microcontroller I'm going to use today. But it's a board called Arduino. Okay, the microcontroller, let me zoom in a little bit. It's this little long black thing. Okay, it is called the ATmega 328P, and it has input and output ports for which you can write to or read from. So it takes a certain hex code, right? You know the very way the computer only understands zeros and ones, that's the same way a microcontroller also understands zeros and ones, right? So it has a processor which is able to interpret the code you write to it. But that code is not what you write like literally, it's a compiled form of the code. Okay, so it goes in the hex form. Then it can use to interpret that hex code and it used to like set some bits high or low and all those things. So Arduino uses that microcontroller to control 13 digital pins, right? And then 5 analog pins, and then some voltage supply, and then the ground. So you can power the Arduino using this USB cord, or you can use the 9-volt battery jack input. Then you can use that to power it. Okay. And this same USB port is used for uploading code to the Arduino. Okay. So let's move on. Then we also need some jump wires to do the connection. So the whole project is centered on one main concept called voltage division. Okay, and voltage division comes from a certain known theory from electronics, that is the Ohm's law. That is the voltage, the potential difference across a resistive device, is directly proportional to the current passing through it, right? So we can know we can know how much current is passing through something if you know the voltage and resistance of the person, right? So this is a simple experiment explaining what the Ohm's law is all about and how it helps us to do potential dividing. So we have some number of resistances here, or resistors of resistances, right? And then we are giving them a 1 volt DC voltage, right? And we are going to measure the net equivalent resistance and the voltage that we measure across. So across means across, right? Across. Let me put one probe here, another one goes to ground. So all these readings is going to be referenced to ground. That means the positive part of the voltmeter or the multimeter is going to put at where you want to, and the negative part goes to ground. Okay, so we measure from here, from this between 4.7 and 33 as the first set of voltage. Then we combine 4.7 and 33 as the next set. Then in that order we'll be increasing them like that. Then we measure the voltages. Okay, and that's the recorded data we have. So we plot a graph of the resistance and then the voltages, and it gives us a linear graph to show us to prove to us Ohm's law, right? That is a linear relationship between voltage and resistance, and that slope of that line is going to be predicted as current, and that's what we are seeing over here. So that means from this experiment, the slope was, from the equation you are seeing here, was 0.198, right? And that was the thing. Okay, so since we now know the current, it's good to know whether we understood what it is. So for the multimeter 2, we were reading about 0.02 milliamps, right? And that's what this one was telling us, that okay, then that means we can use that to approximate that, and we verify Ohm's law. So since we now know that there's a linear relationship between voltage and resistance, we can use that linearity concept, right, to predict the voltage, right, when we know the resistance that we want to predict its voltage, the voltage across it, right? So current is constant, so that means the voltage of the voltage that we want to calculate over the its resistance should be equal to the voltage input over the total resistance. That's the ratio and proportion, right? So that means if you want to find the voltage, we know the resistance, then the total resistance, the ratio of these two guys multiplied by the input voltage. That will give us how much voltage is being dropped across that set of resistances. So X is just telling us that maybe R1, maybe R1 or R12 or R13 or anything of that sort. Okay, and all voltages are also measured with respect to ground. Nice. So let's talk about the potentiometer, okay? So we're talking about voltage division, and since that's the main concept, we need to get a certain set of resistances that would divide voltage into various sections, right? So the potentiometer is a variable resistance, okay? So you can use the knob here. When you tune it, you can tune it, right? And that will give you certain like ranges of resistances. So it has 3 sort of legs, right? And then 2 of them are fixed, and then 1 is variable. So by tuning the knob, you change the position of that middle leg to various points on this resistance rack, right, or track, right? And when it's moving, it breaks this whole arc into 2 parts, this part and that part, okay? So then it forms like 2 resistors inside one big resistor, and this can be used to measure the voltage, or the voltage across maybe this part or across that part, and that will be used to be changing a lot of things. So for our experiment, we're going to use this concept to divide voltage, right, with one end connected to 5 volts, one to ground. So you can divide 5 volts into various sections by just tuning this or turning this knob. Okay, so we can map this that changing voltage to form various combinations, right? So this is a 2D view of what I'm talking about. So this is the potentiometer, right? And this arrow points how the turning. So when I bring it down, so as you can see, below the arrow is this resistance, above the arrow is this resistor. So this is broken into 2, right? So when you right now, that means looking at this, below the arrow is smaller than above the arrow. That means R16 is smaller than this. That means the voltage from here to here is smaller, right? So you can get, by just changing that, you can be changing the voltages, and that's what you're going to need, right, as voltage division. Okay, and here, so that means we can get a voltage, right, across the R16, right, from 0 to 5 volts, right? Then we would map this, right, to numbers from 0 to 99 for our experiment, okay? And also from 1 to 4 to choose operands, right? For like plus, minus, all those things with a code in Arduino, okay? Okay. So now let's look at what a push button is, okay? So a push button is literally like a temporary switch, right? It is a switch while you press it. So it is not maintained. That means when you press it, it won't be there to, like, it won't be on till you unpress it again, right? So while I'm pressing it, it is closed. When I remove my hand, it's open, right? So it's a temporary switch. Okay, so diagonally, that's how it is, a switch diagonally, right? But on this ends, right, can also be you can take it that way too. Okay, on this, like how the point there, like on this vertical line, right, they are connected together. So if I put 5 volts here, 5 volt appears here. If I put 0 volt here, 0 volt appears here. Okay, but when I press this thing, whatever is here moves here or moves there. Okay, and that's how it's functioning. This is a knob or a certain cap you can place on this yellow thing to just give it aesthetics. There's nothing big about it. It comes in different colors, so don't mind the red. Okay, so this is how it really looks in 2D. So as you can see, so when you press it down, it closes the circuit, and whatever is on the right side or left side or this part moves down. Okay, so you can configure the push button in 2 states, right? As a pull up or pull down. Effectively, when you want to use it as a certain input, right? Because when you use any of these configurations, we are sure that any change is easily noticeable. So you could have said that, then why are we adding a resistor here right now? Because we don't want to waste current, okay? And we don't want to be reading flicking results, okay? So when you put 5 volt at this part, and you think about it, when you put 5 volt here, when I press 5 volt to move here, it's easy. When it's not there, you're supposed to receive nothing. But you see, in real life, we don't have anything like nothing. That means some of the components store electricity, right? So if you don't take care, you end up reading 5 volts. Meanwhile, there's supposed to be nothing there, right? So we force the middle of them to get a certain state until it is changed by pressing, right? So as a pull up, I'm zooming in fast, see, okay? As a pull up, we force the reading to be ground by putting a resistor there that will not load current, right? It will not that would reduce current from, because current is that part of the circuit that's necessary for driving a lot of things, right? So we need the voltage to produce current, but we need the current to drive things. We don't want to extract current, or else you reduce the battery lifespan and all those things. So we need a resistor here that's going to make current very small, and also at the same time force voltage, the ground to come here. Okay, so when ground is here from the start, and I press the button down, this power source, whatever magnitude, 5 volt, 10 volt, whatever, will move on press. When I press this, it moves. Then now we get a 1, so pull up. So it moves from a 0 to 1. That's pull up. Okay, and for pull down is the opposite. So we'll force the 5 volts to be here, right, till we press down, then now pull down. That means you move from a 1 to a 0. So whatever voltage is here will appear at this node. So these 2 configurations for us to use in our code to send certain signals to carry out certain tasks. Okay, so a 4/7 segment display, as the name suggests, it has 4 segments, for which every 4 displays of 7 segments, right? So 4, 1, 2, 3, 4, 7 segment displays, right? So 7 segment display, as the name is, has 7 segments. So 1, 2, 3, 4, 5, 6, 7, right? And it has this dot here for in case you want to make decimal points, but we are not going to consider it for anything. Okay, so this thing it's really interesting how it functions. We'll talk about it very soon. So this is how one 7 segment display looks like. So you see here there are 4 of them, but this is a single one. Okay, so let's look at how it looks like in 2D. So we're looking at 7 segments, 1, 2, 3, 4, 5, 6, 7. Okay, if I zoom in a little bit, you see that there's an A here, a B here, okay, a B here, a C here, a D here, an E here, okay, an F, and then a G, okay, but they all have a D1 key, D1, D1, D1. That is called a common point of all the segments. So a 7-segment display is usually like 7 LEDs that are all meeting at one point, either with their positive side or their negative side. So if all their negative sides are meeting, then we need D1 to supply a ground for all the LEDs to be either powered on or off, right? And that's actually all. So you have this. So the A1, B, whatever are going to be controls from a certain microcontroller, right? That's why you need a microcontroller. So if you look at this place here, this is the control for the pins, okay? So they have 7 transistors, right? That when you enable current through the base or remove current from the base, okay, fine, that remove is a very wrong word. So when you either send a 5 volts or a ground, or you enable current to flow through, or like let's leave it still, you activate the switch. So you making a transistor act like a switch. So you activate the collector emitter, right? The base collector or the collector base. Then when you activate that like those two PN junctions, they can cause current to flow from the emitter to collector or collector to emitter or normally from collector to emitter, okay? So you're going to be using these ones to control the 7 segment, that is A, B, C, D, E, F, G, or whatever. Yeah. Okay. So now let's look at the first. So this is how the 4 7 segments look like in schematic. So you can see 4 of these guys are here, and all these 4 have a common E, a common B, a common C, a common D, a common whatever. But each and every segment have their own control, their own Ds. So from before, here was only D1, but right now we have D1, D2, D3, D4. Okay, so we need this D1, D2, D3, D4 to allow us to permit, right, which segment to display something on. Okay, it's going to be like a certain like enable pin, okay, that will allow us to choose which parts to do this. And we are doing this using a concept called multiplexing, right? So multiplexing ensures that we use small number of wires or small number of pins to control a large number of things, right? So these 7 segments, that means we have 28 segments. Literally, we need 28 pins to control each segment. But with multiplexing, you're going to use 11. So that means you only need the control for just one, and then now you need the digital pins, the enable pins, right? So when I turn this one on, then that means I can use only this one to display, or this one to display. And then if I want to use right to all of them, you're going to do it so fast that our eyes will just see it as if this like they are all be enabled, okay? And there's very beautiful concept behind understanding electronics. You will reduce a lot of costs, and then you would be able to effectively utilize what you have. So from the actual 4 7 segment display, this is the pinout for it, right? For the A, B, C, D, and then the D's I was talking about. So from this device, so this thing, the pins here, these are where you need to connect your microcontroller's pin out to, and then you will be able to control the segment and write your program to it. Okay, so for our calculator, don't worry, it's not difficult, okay? Don't mind the schematic, just telling you that a lot of thoughts go into it, and it's as easy as you see it, okay? So you have 4 segments, right, that have controls for controlling them from Arduino board, right? And then we have this one, it's just for it's a virtual terminal used to display serial communications, just to show us that all those things. And then we have our 2 push buttons, okay, configured as pull up, and this our potentiometer here. Okay, it's a schematic, so it is made with Proteus, and Project a software for making electrical simulations. You can download it. Okay, so we are done with walking you through all this thing. So then why are we going through all this understanding before we actually show you the schematic? You need to know how things function, right? Understand the concept behind it, then you shall be able to use them in your project, right? Example, understanding how the microcontroller really works, right? So you need to know which pins to use for what, right? And since a potentiometer, for example, a potentiometer like this, is going to have values that are not 0 or 1. We want to measure values between 0 and 1, maybe 0 0.1, 0 0.2, 0 0.3, right? So you need to know which of the pins on the microcontroller accept such inputs. Okay, if you use digital, it's only going to be a high or a low. So you can't know like whether this is 0 0.1 or it only knows that it's higher than 0, so it's 1. Then we have analog pins also, okay, that can read actual values. So that's what we're going to be needing for our project, and understanding all these things will help us make this pretty successful one. So just keep on watching while I walk you through the code and the other ones. This is the program behind the project, and it is written in Arduino IDE using C++ syntax. So this is machine code, so you may be seeing some things that look weird, but I just follow along. Maybe we would all manage to understand later. So you need to declare some variables, initialize them with data types integer. Okay, when you're declaring any Arduino pin, you need to use the integer data type, and then the constant here is a modifier to show that this value does not change throughout the program. And as I was saying, the potentiometer pin needs an analog pin because we're going to read different voltage values instead of a 0 or a 1, right? And these are the two push buttons that we're talking about, the two pull-up input push buttons. So we need these push buttons for two things. So this one would allow us to toggle to like select new, like after selecting the first number, we press it, that means you are done. Then we select the symbol, we press it, that you are done, we select the next number. Then we use this push button to indicate that, to tell Arduino that okay, now you can add those input or like perform the arithmetic operation. So these are some variables that you've declared, symbols, numbers, and all those things to just help the program run well. So, and this another important part too. So the display, the 7-segment display, the 7-segment display. Okay, these are the pins you are given. So the number of pins you're going to use on this, you're going to use seven segments, so 7-segment display, and how many digit pins, how many control pins, 4, right? Okay, and we create an array of the segment pins. Okay, as I was saying, they are Arduino pins, so we use the int, right? So you don't want it to change, so constant int. Okay, and then we pass in these various pin numbers on the Arduino. That means from pin 2 to pin 8 of the Arduino are going to be used for controlling the 7 segment, right? And then pin 9 to pin 12 of the Arduino are going to use to control the digital pins. That means D1, D2, D3 to enable which of the segment to display. Now these are patterns that we need to write. Okay, so to display anything, we need to know how the pattern is. Okay, so looking at 0, right, the 7 segment. So I want you to imagine it 1, 2, 3. Let me see if I can show you the picture. Let's see. Okay, so it won't be able to show for you to see, but I hope it does. Okay, you won't be able to see it. Okay, don't worry. So imagine it being drawn like that, right? So for this is the pattern we need to turn on, or to show a certain, to show 0, right? To show 0, every other pin must be on except for J. Okay, J is the center LED. So if we turn the center LED on, we form a 0. Then these are patterns to draw 1, 2, 3. It's an array, so it's a constant array. We don't need to even worry about it. Just you can form as many characters you want to form as far as you get the clue. Then a lot of things, and I'll talk about this in the end of the video. I added this thing because one caution about using the 4/7 segment display is understanding that they are LED, so they can burn. So excess current can cause them to die out or burn. Okay, so I'm doing maximum answer as 999 because instead of 4/7 segment displays, it's now 3 because one of them got destroyed in the course of the testing stage. So a caution, whenever you're using these displays, be very careful. Learn to add resistors to the digit pins, okay, the digit pins, or else you would cause current to high current, maybe about 1k resistor, just one. You can use just one resistor so that the LEDs will be very bright. Okay, so this is also an array for the digital pins. Okay, this is for the like to enable them. So as you can see, the digital pins are going to be like the ground for each segment. So when you see to enable digital pin 1, we set that one to off, the rest should be on. So this is how you're going to be enabling them using another function or something. So in Arduino there are two principal functions you should know. That is void setup and then void loop. Okay, in the setup we declare variable and we initialize variables, and then we set them the pin modes and stuff, and it runs only once in the program. And here, so pin mode means the pin that you're going to use it. How should the pin be used? Is it like going to read an input, or this? That's for the microcontroller. Okay, so we want to make the push button, the potentiometer, and then the solver pins as input. Okay, input pull up means we are making it such that like when there's a move of 0 to 1, right, then you should receive the input. Okay, and the input is just like you don't really care whether 0 or 1, just read whatever it is. Okay, so when you do input pull up, you enable the internal pull up of the microcontroller, which is also going to be useful too. Okay, but you can make it input because we have done the pull up manually, but I just left it there just to explain something. So we are also going to declare the segment pins. That's the ones to control the A, B, C, D, E, F, G as output. That means that we are going to be sending voltages, right, to it as output, and then the digital pins to like the enable pins also as output. And then we first of all at the beginning, everybody they want all of them should be off, so then we set all the segment pins to be off, and then we turn the digit pins on because when they are off they are enabled. Okay, so in the void loop we are doing two things. We read the data from the potentiometer, and what do? We map it, right, as I was saying. So first of all, we want to map it for 1, numbers, and 2, symbols. So min val and max val are variables that help us to do this. So at the beginning of the program, min val is 0 and max val is 99, right? And then this is going to help us choose a number between 0 and 99. Okay, and when we map that, we store that information. Okay, we break the data into 4 4 different digits, right, so that we can display it on the 4/7 segment display. So we have a function called myDelay that takes all the digits that we've broken up. Okay, and then how many seconds you should display that, and then this one just to enable whether you should use all 4 or 3 or 2, and that's what it does. So this is the button states for the 2 push buttons. Okay, the first push button with an analog read, which is also read analog values, but I could have used digital read, but I just wanted to use analog to explain something to you. So the analog read, right, can read between 0 and 1023. Okay, and it will map the response, right, to 0 to 255, right, if you want to analog write. So I am choosing any range to map it to. Okay, so like I use that to make a certain comparison. So 0 is like low, 1025 is like full voltage, right? So in this case 0 will be low and 255 will be full voltage. Then we can come here and then do an if statement, a certain condition that whenever the push button, okay, was reading something high, that means the button 1 that was for push, okay, when it was high and the previously it was low, that means we want to do a rising configuration. That means first of all it was like as I was saying, pull up, okay. So if it was a low and then you press and it was a high now, then we can wait for some seconds, take the data that it was given, right, set calculate, there's variables to do some things, okay. So inside here, this is how we do the toggling, okay. So from here we display that this is the first number you've chosen, we display it to you. We indicate this negative one here was just used to just show something onto the 7-segment display to show that you've pressed the push button, okay. And then we change min val and max val, okay, so that we can use to choose the operand, okay. After you choose first number, you can now choose operand with 1 to 4. Then it will go back again, okay, in the following, then it will start again. Then if you press it again, then it will come here. Then it will also choose the operation symbol according to the number you choose, right, 1 0, and to map it out. And then we will set it back to 0 to 99 for you to choose the second number. Then you do similarly for here too. Then we set it back to its original form. So we'll be doing this thing to further notice till we are done. Then after you've chosen the second number, we can now allow you to calculate. To calculate is 1, right? So then we take note to the previous we are seeing from here, okay. We always store the button push 1, that means the one that will help us toggle between numbers and symbols, right? We store its reading every time before a new one comes, to know whether it was a pull up or it was a pull down, okay. If you're doing interrupt, you could have called it a rising interrupt, okay. Then we have this 1 2 4 button 2. So if the button state is greater than 100, that means you're receiving some amount of voltage. Then we check if we should calculate, right? If that means the button 2 state is for the solve, right? So if calculate is enabled, then we send the number 1, number 2, and then the operation, okay, the operation symbol. We pass them inside the operation function, and then it does the operation, and then we get we also display that thing, okay, to indicate that you've pressed some dashes, some short dashes to show that you've pressed something. And we wait for some seconds. Then I will now display the answer for you, and we will see all these things in the demo. And that's actually all we do, okay. So in operations, as you can see, it takes number 1, number 2, and then the symbol, right? So we come here, we switch the symbol. If it was a 1, that means an addition. Then we add the 2 numbers. If it was a 2, we take the absolute of, because we can't display negative value, so we will take the absolute of the 2 and then write the answer. Then if it was a 3, now the division, multiplication. If they didn't choose anything, it wouldn't even reach here because the code will not even allow it. Then we do all these things, and that will be it. So now we have another option so that in case you want to do just to indicate something. This is not really anything, it's just for us to indicate to the person that you've clicked something. Then this function does nothing anyways. Then to display a number, right, we need to set the segment like to display a certain number, right, for a certain number of seconds on the 7-segment display. We need to write the pattern, okay, that this array that we created from the top. Like for 0, we need to do everything on a self chain, so we have to write the pattern to the segment pins accordingly, right? And wait for a second, that's what we do in this function. Then to reset, of course, digit pins must be on, okay, because they are ground. So, and then segment pin must be off. Sorry for that. Then to enable a certain gate pin, we go to the gate pin array, right? the enable I was talking about. So for this part, right? So I was talking about some enable bits like this ones. So we come here and write the corresponding states of the pins to the corresponding pins. Excuse me. Okay, so that's usually it for that part. Now, as I was saying, to display the numbers on the thing, we enable the pin. We write the corresponding number to it. We enable the next pin, corresponding number, right? They are all being written in some number of seconds. So you need to know the speed of it so that the person does not even realize, that the eye cannot even see, right? So and this is an optional one, so that you can choose to write to some pins or otherwise, right? And because one of the segments got started or got destroyed, I had to remove one of the segment display, just use 3. And then getDigit is a function that will loop over the number of to loop over the number, like a while loop, and extract all the digits inside the number. So if I have 23, to break it into 2, 3, right? So I can write them separately on the segment. So this is the function that actually implements the fast movement, right? So we give it, instead of creating a delay, we create our own form of delay, our own delay, right, for the multiplexing. So the number, if I want to go for 1 second, right, I divide the 1 second by 4, convert to an integer because it's a for loop, okay? And then it's not because a for loop, because I'm using an integer as an iterator, so I need to convert this into, or else it to be 25 point something, right? Then I come to this one, I call the for 7 segment display function, passing number 1, number 2, number 3, number 4. Then I'm going to write them at 1 millisecond. That is extremely fast. In fact, 100 milliseconds is so fast, so in 1 millisecond is extremely fast. Okay, then we write them that, and then you write the option according to what you write. And after writing every number, we reset the thing. That means we want to turn the display off till the next number comes. Okay, so that's actually all the code is about. And this how many lines of code? It's just 285, which is not too long because I understand that one. Okay,
so this is the demonstration of the project, and as you can see, this is the potentiometer I was talking about. This is the push button 1 for toggling numbers and symbols, and there is the solve push button. These are 10k resistors for reducing current, and they are used for the pull-up configuration. This is the Arduino Uno board connected to my laptop. This is the battery power supply with this USB cord for powering it. That's the 4/7 segment display, and I come to demonstrate how to use it. So to choose the numbers, you just tune the potentiometer, and you can look at the numbers change over there. So I want to choose about 30 something, so let me choose 33. Okay, then when I want to select it, I press this push button, and then that's it. So then I can now choose the operation. So 2 is subtraction, 1 is addition. Then you can be looking at this LED, okay, to show you that you're increasing voltage. Okay, so 4 is division. I want multiplication to 3. Okay, so let me do it up. So this multiplication, so then I can choose that I'm done. Okay, then I can now choose the second number. So I want to multiply a number by that easier one. So if I choose 2, so now times 2, right, that will be 66. Okay, so then let me select that number. Let me choose 2. That was a big number. So 2, 2, 2, 2, 2. Okay, so that's 2. So when I choose 2, great. So if I press the solution answer, we're expecting an answer of 66. So let me press it. So that's it showing there 066. And this is how that works. Now you can see that this third segment was flickering and having some problems. Yeah, because there was too much current passing through it from the testing stage. So I'd advise that whenever you're using the 4 segment display, you use 1K resistors for all the 4 digit pins, not for all the 7, just for the 4 control enable pins, the 4 digit pins, so that you control the current and maximize the brightness of the LEDs. Yeah, so thank you very much for watching.